students, welcome to all of you in Network Professional, the Cisco Networking Academy, and I am your instructor Ahmed Malik. Welcome to all of you in CompTIA Lecture 5. So let's take a start. In our previous lecture, we discussed about the power supply, some safety precaution measures, CPU case and CPU fan. But in this important lecture, we will discuss about the installation of motherboard, CPU and RAM and how to assemble a computer. So let's take a start. When building a computer, choose a chipset that provides the capability that you need. For example, you can purchase a motherboard with a chipset that enables multiple USB ports, eSATA connections, sound card and video cards. The CPU package must match the CPU socket type. A CPU package contains the CPU connection points and materials that surround the CPU and dissipate heat. Data travels from one part of a computer to another through a collection of wires known as buses. The bus has two parts: the data portion of the bus, also known as data bus, that carries data between the computer components, and the other one is address portion, also known as address bus, which carries the memory addresses of the locations where data is read or written by the CPU. There is also another third type of bus that is known as control bus, used to control both data and address bus. The bus size determines how much data can be transmitted at one time. A 32 bus transmits 32 bits of data at one time from the processor to the RAM or the other motherboard components, while on the other hand, a 64-bit bus transmits 64 bits of data at one time. The speed at which data travels through the bus is determined by the clock speed measured in megahertz or gigahertz. At this point, remember that this clock speed of your motherboard, CPU and RAM must be same for compatibility. PCI expansion slots connect to a parallel bus which sends multiple bits over multiple wires simultaneously. While PCI expansion slots have been replaced with PCIe, also known as PCIe Express expansion slots, that connect to a serial bus which sends one bit at a time at a much faster rate. When building a computer, choose a motherboard that has slots to meet your current and future needs. When selecting a replacement motherboard, make sure that it supports or accommodates CPU, RAM, video adapter cards and other adapter cards. Sockets and chipset on the motherboard are compatible with the CPU, the existing heatsink and fan assembly when reusing the CPU. The number or type of expansion slots, they must match the existing adapter cards and allow for new cards. The existing power supply connections must fit the new motherboard. New motherboard must fit into the current computer case. So let's take step-by-step installation of motherboard. The step 1, align the motherboard in the correct direction. Step 2, locate the standoffs. Step 3, install standoffs in the computer case. Step 4, align your I/O plate to back the computer case. Step 5, lower motherboard into place. And finally, step 6, install the screws into the standoffs. But theoretically, it's not possible to understand how to install motherboard. So let's have a video demonstration to understand how we will install the motherboard.
Hello everyone, can you believe it? We're going to install the motherboard with the CPU, heatsink, and RAM into our computer case. Before we just paste the motherboard into the computer case and call it a day, first you need to install the standoffs into our computer case. These standoffs will be used to secure the motherboard in place within the computer case. Some computer cases will have built-in standoffs, like mine for example. Others, you'll have to take a standoff and install it yourself. These standoffs are commonly small, and you'll screw it in using an adapter that comes with the standoffs. In order to locate standoff locations, it is best to take your motherboard and practice placing it into your computer case. Step 1 is to align the motherboard in the correct direction by having our adapter ports facing on the back of the computer case. So we'll take our motherboard, the motherboard is resting in the case. Step 2 will locate the exact standoffs that are needed by looking at the screw hole locations. If you take a close look at it, you can shift the motherboard and we'll be able to find the exact screw hole location that'll be needed. Step 3 is to remove the motherboard and then screw in the standoffs at the correct locations. Since my computer case does not require this step, we're going to continue on. Assuming you've installed your standoffs, step 4 is to take our I/O plate, input-out adapter plate, and align it on the back of our computer case. This will provide adequate dust and airflow for our computer case. Let's position the I/O adapter plate with the writing and ports in the correct direction. If you install the I/O adapter plate upside down, the motherboard won't be able to fit correctly. So make sure that it's correct. As you put the plate into place, give it a push in each corner and along the edges, and you'll hear it snap into place. Take your time on this, as some adapter plates are plastic, while others are metal. They are possible to bend and or break. Now that the plate is installed, put the computer case back on its side for step 5, lowering the motherboard into place. Let's finish installing the motherboard. The key of installing the motherboard is to put it into the case at the correct angle. As we place it in, we need to align the I/O ports of the motherboard with the slots of the I/O plate. If I pick up the case, we should be able to see it resting nicely. At this time, we can use our screwdriver for step 6, installing the screws into the motherboard standoff. One by one, we will install the motherboard screws. Make sure not to install the screws too tight, as you don't want to crack the motherboard through excessive force. Don't worry about the screws being not overly tight, as we have a good amount of screws to keep this motherboard in place. If you choose to upgrade your CPU or heatsink in the future, some gaming and high-performance heatsinks actually require you remove the motherboard and install a special plate to the back. Let's get started installing those screws. Now that all the screws are tightened, we are good to finish our build and continue on to the next video. Who knows, you might be removing your motherboard and installing it again in the future. Get your practice with us here for installing a motherboard into a computer case.
In video assembling, another important part is CPU and CPU cooling. Before you buy a CPU, make sure that it is compatible with the existing motherboard. Manufacturer websites are a good resource to investigate the compatibility between CPU and other devices. The table in figure 1 shows the various sockets available and their supported processors. The speed of a modern processor is measured in gigahertz. A maximum speed rating refers to the maximum speed at which a processor can function without errors. Two primary function factors can limit the speed of a processor. The processor chip is a collection of transistors interconnected by wires. Transmitting data through the transistors and wires create delays. As the transistors change their state from on to off or off to on, they create a small amount of heat. The heat is also created when the speed of our processor increases. When the processor becomes too hot, it begins to produce error, so it must be kept cool. The front side bus FSB is the path between the CPU and north bridge. It is used to connect various components such as the chipset, expansion cards and RAM. Data can travel in both directions across the front side bus. The frequency of bus is measured in megahertz. The frequency at which a CPU operates is determined by applying a clock multiplier to the FSB speed. For example, a processor running at 32 megahertz might be using a 400 megahertz FSB. 32 megahertz are divided by 400, that is 8 megahertz. So the CPU is 8 times faster than the FSB. Processors are further classified as 32-bit and 64-bit. The primary difference is the number of instructions that can be handled by the processor at one time. A 64-bit processor can process more instructions per clock cycle than a 32-bit processor. A 64-bit processor can also support more memory. To utilize the 64-bit processor capabilities, ensure that the operating system and applications installed also support a 64-bit processor. The CPU is one of the most expensive and sensitive part of our computer case. The computer can become very hot. Therefore, most CPUs require an air-cooled or liquid-cooled heat sinks combined with a fan for cooling. So let's take a step-by-step installation of your CPU. Step 1. Orient the CPU to the CPU slot. Step 2. Press the CPU into the CPU slot. Step 3. Lock the CPU into the CPU socket. Step 4. Apply thermal paste to the CPU to keep it cool. Step 5. Also install a heatsink to keep your CPU cool. And finally, step 6. Secure the heatsink. So let's have a video demonstration to learn how to install CPU in our motherboard.
We're going to install a CPU, Central Processing Unit, into our motherboard. Here's an exercise that is not commonly done in the classroom. We're going to take a CPU, like this chip here, and we're going to install it into our motherboard slot. Now what we must do is orient the CPU. Step 1 is locating pin 1. Pin 1 is usually what indicates how the CPU orientation should work. We have a triangle, which we'll be able to see right here. Let me zoom in. And this triangle is what's going to inform us of the alignment of pin 1. Now, if we go to our motherboard and we open up our mother slot, if we look closely, what we'll be able to see here as well is that same triangle marking. And that triangle marking is right here, which shows us the orientation for our CPU. Now, our CPU also has a keyed slot on it, and on the CPU on the motherboard housing, you'll also be able to see here that we'll be dropping the CPU, and there's keyed slots to ensure that it's correctly aligned. Now that we know how it should be aligned, step 2 is to safely lower the CPU into the CPU slot. For step 3, we can lower the CPU housing and lock the lever into place to hold our CPU firmly in place. For step 4, it is important that we take some thermal paste and we're going to place a pea-sized drop carefully on the top center of our CPU. This thermal paste will help the distribution of heat from the CPU to the heatsink that we will install next. Now, to keep this CPU cool and prevent it from overheating, we are going to install a heatsink for step 5. These commonly have a fan attached to them, but not all of them do. These fins we see here are going to absorb the heat from the CPU and have slots for airflow to move in between. The fan on top of the heatsink will help draw the heat away and cool the fins. This will allow them to absorb more heat from the CPU. As we attempt to place the heatsink on the motherboard, it may take 1 to 2 attempts to position it correctly over the screws that are going to surround our CPU. The final step, step 6, is to screw down the heatsink. After positioning the heatsink correctly so that it aligns with the heatsink screws on the motherboard, we will screw in the 4 screws in a specific order. It is best to screw one corner first and then go to the opposite corner diagonally from it. This will help ensure we have a flush connection between the CPU and thermal paste and the heatsink. As I mentioned, we'll go diagonally across to the other corner. Now we can continue our last 2 screws. Now that all 4 screws are locked in, the heatsink will not be able to move or shift at all. Having a tight flush fitting will also allow the CPU to better stay cool. Thanks for watching our CPU install.
Another important part of our computer is a RAM, also known as random access memory. New RAM may be needed when an application locks up or the computer displays frequent error messages. To determine if the problem is RAM, execute the RAM test in BIOS. The speed of new RAM must be supported by the chipset. If we are using a 64-bit system, we need a 64-bit RAM, and if we are using a 32-bit motherboard, we need a 32-bit RAM. They can be single slot or they can be multiple slot. Memory may also be categorized as unbuffered or buffered memory. Unbuffered memory is the regular memory for computers. The computer reads data directly from the memory banks, making it faster than buffer memory. Buffered memory specialized memory for servers and high-end workstations that use a large amount of RAM. These have a control chip built into the module that assists the memory controller in managing large quantity of RAM. So let's have a step-by-step installation of your RAM. Step 1. Open the RAM slot levels. Step 2. Orient the RAM chip to the motherboard slot. Step 3. Lower the RAM chip into the slot. And step 4. Press down firmly to lock the RAM. So let's have a video demonstration to understand how to install RAM on our motherboard.
Hello everyone. At this point in time, we have our power supply installed in our case. We also have our heatsink installed on top of our CPU, which is locked into the motherboard. Now, before we move this entire setup into our computer case, we will install the RAM modules. These are the RAM modules. It's much easier to install these now than after to have this entire setup screwed into the case. On our motherboard, we have 2 slots to add RAM. Take note of where the notches are on the RAM slots on our motherboard. Right here and right here. These notches will line up with the notches on our RAM. Step 1 is to open the levers on the RAM slots of the motherboard. We're going to open them as far as they will go. They're going to click into place. This should require almost no force. Step 2 is we're going to line up the RAM module in the correct direction for the slot and notch. Step 3, we're going to slowly lower the RAM module into the slot. Step 4, now use your thumbs to press down on both sides of the RAM module, and you feel the RAM module will be locked in by the 2 lever arms on the motherboard. Next, we take the second RAM module. We'll verify the alignment again, based on the notches on the motherboard RAM slot, and we'll press the RAM module down vertically using both of our thumbs again. Give it a push downward using your thumb on the left and on the right. As it clicks in, now the RAM modules are installed. It's exciting.
So dear students, thanks for watching this video and stay connected for all the upcoming videos. Thank you very much.